Yes, dear students, in continuation of series of numerical physics and MCQs, we have a question which is based on the mechanical property of solid. In this question, two opposite forces F1 which is of 160 Newton and another force F2 which is equal to 120 Newton act on an elastic plank of modulus of elasticity y is equal to 2 into 10 raised to the power Newton per meter square and length 1 meter placed over a smooth horizontal surface. If the cross sectional area of the plank is S which is equal to 0.5 meter square, the change in the length of the plank is in nanometer. We have to calculate it in nanometer. Now if we go through this plank, a force which is acting in this direction, another force is acting in the opposite direction. So these two forces will stretch it in both directions. So there will be tension in this direction T and in another direction is also T. So there will be a change in the length, or we can assume the thickness that is dx, a very small dx. And if we go through this, so change in the length of the plank that we can calculate with the help of Young's modulus of elasticity. We know very well force per unit area delta L into L. Here we have assumed the thickness dx, so it is F into dx upon area that we have taken here, it is S, and y, so it is delta L. This is the formulation which we will use to calculate it. Now for calculating this we need to know the force, and for knowing the force, if we see it, there are two forces acting. One is F2 and another one is F1. So if we consider it, it will be the tension in it, and one side tension which we can have F1 minus F1 minus F2. This tension which is acting F1 minus F2 into x upon L. So if we substitute this value in here, in this, we'll have F1 minus F1 minus F2 into x upon L into dx, and we can put it like this: 1 upon s into y into delta L. Here we can take change in length, that is dl. So dl will be 0 to delta L, and if we integrate it also with 0 to dl, 0 to L. L is the change in the length of the plank. Okay. So here 1 upon sy is common. Integration of this, because it is the value which we have to put it like this. So it is f1x, it is f1 dx, f1 into x, 0 to L, minus this f1 minus f2 as it is, it will be x square upon 2 into L, and it is 0 to L. Now if we go through this, I am putting it here, this relation here, delta L 1 upon sy, and integration and putting the limit will give the 0 here, f1 into L, and another is lower limit, that is 0. Now here it is f1 minus F2, value will substitute L square upon 2 into L, lower limit will be 0. So we have here 1 upon S into Y, that is F1L minus F1L by 2, and it is plus F2 by 2L. So here we will have relation 1 upon S into Y, F1 plus F2, okay, F1 plus F2 upon 2. What is F1 2? It is L, sorry, here it is L. So it is F1L and L is here. So we have got the change in length in terms of this delta L that we have to determine 1 upon S, S is 0.5 meter square. Young's modulus of elasticity, that is 2 into 10 raised to the power 11. F1 is given to us, that is 160. F2 is 120, and length in meter is also given to us 1 meter. So we are substituting it here. Now we have 280 upon, we have to multiply it with 2 also. So it is 2 into this 1 and to 10 raised to the power 11. Now it is 140 into 10 raised to the power minus 11. We can put 14, 140, 14 into 10 raised to the power minus 10 meter. So if we convert it into nanometer, it is 14, 1.4, because if we multiply it with by 10 and dividing it by 10, it is 10 raised to the power minus 9 meter. And the delta L which we are going to have 1.4 into 10 raised to the power minus 9 meter, means the correct answer is 1.4 nanometer. Okay. So while doing such type of questions, we have to formulate in the required format. हमको उसको फॉर्मुलेट करना पड़ेगा, एंड जब एक बार हमने इसको फॉर्मुलेट कर लिया तो क्वेश्चन को करना आसान हो जाएगा. तो इस तरीके से हम जो क्वेश्चंस हैं मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड्स पर बेस्ड उनको कर सकते हैं.